Welcome. We'll introduce you to the essential components that make up a drone, including motors, propellers, flight controllers, batteries, and more. Learn about the tools you'll need for a smooth assembly process, ensuring you have everything ready before diving into the exciting world of DIY drone building. Today we are here to introduce assembling and configuration of the drone with DJI Naza M V2, your comprehensive guide to building, customizing, and troubleshooting drones. Whether you're a hobbyist, a tech enthusiast, a student, or an aspiring entrepreneur. Let's start by assembling the frame. This is arm we want to attach motor to it. This is clockwise motor. First we want to mount all motors to the arm one by one with screws that are provided by the manufacturer. Make sufficient tightness and fix it properly. Here we use two types of BLDC motors, clockwise and anti-clockwise. A 1000 kV BLDC motor is commonly used in drones for quadcopters. It spins at approximately 1000 RPM per volt of input and requires specific voltage ranges. Here we use 3S, 11.1 volt or 4S 14.8 volt LiPo batteries. The BLDC motor has no brushes. For ensuring efficiency and reliability, choosing proper motors and compatible propellers are essential for optimal performance. Here is assembled arms with motor. Then move on to assemble arms to power distribution board. This is the power distribution board. This is an anti-clockwise motor. We want to mount arms with motor to power distribution board, also mount landing gears. Here it is. Attach the arm with motors to the drone frame. Make sure to use the correct motor for each corner of the frame. Attach the corresponding clockwise or anti-clockwise motors. Typically, the motors with clockwise rotating propellers are installed diagonally from each other, and the motors with anti-clockwise rotating propellers are installed on the other two diagonals. Place the drone in the forward direction and count each motor from top right to bottom right. We want to rotate motors 1 and 3 in a counterclockwise direction. Fix the motor as per the direction and place anti-clockwise motor at top right. Fix each arm with the designated mounting holes on the frame and secure them using screws. Ensure that the arms are firmly attached and properly aligned. Set in forward direction. Fix the clockwise and anti-clockwise motors as shown in the diagram. cut each motor connectors to solder motor terminals to ESC. Align each motor terminals that we want to connect to ESC. Connect each electronic speed controller to its corresponding motor. Identify the motor wires and connect the wires. It is an anti-clockwise motor, so we want to connect first pin of ESC to 3 pin of motor second pin, or same for both clockwise and anti-clockwise motors. Connect third pin to first pin of motor as shown in the diagram. Put heat shrinkable tube to secure each wire separate from each other to avoid contact with other. Solder each terminals properly to avoid any loose contact. The ESCs regulate the speed of the motors based on the signals from the flight controller. Exchange pin 3 and 1 for clockwise motors, as shown in the diagram. Connect 2 terminals of ESC to the power distribution board. It is a crucial component in drones. The ESC is responsible for controlling the speed and direction of the motors in response to the pilot's inputs from the transmitter. We want to secure each ESC with cable tie. DJI Naza M V2 flight controller is a popular and advanced flight control system designed for multi-copter drones. Mount the flight controller on the drone frame. The flight controller is the brain of the drone, and it stabilizes the drone during flight and processes input from the remote control. Mount the DJI Naza M V2 flight controller to the frame using double-sided tape. Ensure that its arrowhead is correctly placed in forward direction. Then connect the Power Management Unit, PMU, to the flight controller. Connecting the Power Management Unit, PMU, to a drone typically involves integrating it into the drone's power system to provide regulated power to the flight controller and establish connection between GPS and microcontroller. Connect the input terminal to power distribution board. Then we want to connect battery terminal to power distribution board. Mount the receiver on the drone frame, then connect the receiver to the flight controller. This allows the drone to receive signals from the radio transmitter, enabling remote control. Mount the receiver to the frame using double side tap. We can connect input supply to flight